Hello, my name is Erin Kazar. I'm a student at the University of Louisiana at Monroe. Today I will be talking to you about writing research problems and questions. Today we will be discussing the definitions of a research problem, grouping similar variables, types of research questions and formats, and types of statistics used for each question. And of course we will have a reference list. A common definition of a research problem is a statement that asks what relationship exists between two or more variables. For instance, what is the relationship between variable A and variable B? Here's an example. Is there a relationship between pre-entry doctoral students' characteristics and doctoral retention? Research problems are more complex than this. They should be broad statements that cover specific research questions to be investigated. The format is as follows. The research problem is to investigate whether, and then we see that in yellow we put in all of the independent variables. And we look at how they are related to, in orange, the dependent variables in the population. So when you are using variables, we need to be able to group similar kinds of variables. So we use broad descriptors. For instance, a descriptor called demographics may include variables gender, education, and ethnicity. Or a descriptor of spatial performance may include variables such as the mosaic pattern test score and visualization test score. Every study except a true descriptive study should look at two variables, independent and dependent variables. Here's an example. If you are using a randomized experimental approach, this type of research problem statement would be used. The research problem is to investigate the effect of a new curriculum on grades, math attitudes, and spatial performance in high school students. If you are looking or using an associative approach, this statement would be most useful. The problem is to investigate whether gender and grades are related to mathematics attitudes and achievement in high school students. Here's an example of your research problem if you are using several independent variables. The problem is to investigate the variables that predict or seem to influence mathematics achievement. Notice that we use broad descriptors to describe all of the variables being used. Here's an example of a research problem in the real world. This is from a peer-reviewed article cited at the end of this presentation. This study assessed pre-entry variables of 81 doctoral students who graduated from a doctoral psychology program or who withdrew from the program. To answer the research question, are there specific student characteristics at time of admission that may help predict whether a student will complete a doctoral program? Take a look at the yellow. This is where you would place your independent variable. The orange is where you'd place the dependent variable or variables. And the green is the discussion of the type of population. So, now that we know about the research problem and how to state it, we're going to look at some frameworks for stating research questions and hypotheses. If your question is not randomized experimental, you should phrase the question or hypothesis in such a way that it does not imply cause and effect. This is important because the types of statistics used to answer the questions are not looking at cause and effect. For instance, if you were going to do a descriptive or write a descriptive question, you would use descriptive statistics. If you are writing a difference or associational question, you are using inferential statistics. These do not imply cause and effect. So the types of research questions covered in this presentation today are basic descriptive questions, complex descriptive questions, basic difference questions, complex difference questions, basic associational questions, and complex associational questions. So for a basic descriptive question, we are looking at central tendency, frequency distribution, percentage in each category, variability, or the shape of the distribution of a variable. These types of descriptive questions also describe demographics or a dependent variable. Here's an example. Is mathematics achievement distributed approximately normally? What percentage of participants is of each gender? What are the mean, mode, and median of the mathematics achievement scores? If you take a look, all of the orange items are dependent variables. The yellow item is an independent variable. A complex descriptive question looks at two or more variables at a time without using inferential statistics. In this type of question, we would use cross-tabulations of two categorical variables, factor analysis, or measures of reliability to discuss or answer the complex descriptive questions. Here's an example. What is the internal consistency reliability of the pleasure scale items? What are the percentages of males and females in each of the three religious groups? Again, look at the orange item. This is our dependent variable or variables. If you look at the yellow items, these are our independent variables. Notice that in a complex descriptive question, we are looking at two or more variables at a time without using inference statistics. So here's the format for a basic difference question. Are there statistically significant differences between the number of levels is inserted here? Then you also put in your independent variables. Look at the yellow item. In regard to the average, and then you're going to list your dependent variable, scores. Are there statistically significant differences between the three levels of father's education in regards to the average mathematics achievement scores of the students? Is there a statistically significant difference between males and females on the visualization score? Notice that on the top where we see yellow, I have inputted the independent variable. Where we see orange, I've inputted the dependent variable. And also remember to include your population. So formatting for a complex difference question is as follows. You use this format when you're looking at two categorically independent variables. You'll have three research questions or hypotheses when using this format. Notice where the yellow is, that's where we insert independent variables, and the orange is where we insert the dependent variables. Let's take a look at a real-world example. Is there a statistically significant difference between students who have high versus low math grades in regard to their average mathematics achievement scores? Is there a statistically significant difference between male and female students in regard to their average math achievement scores? Is there a statistically significant interaction between mathematics grades and gender in regard to math achievement? Again, yellow variables are independent, orange variables are dependent. For basic associational questions, we are looking at variables that are ordered and continuous. There are two types of associational statistics used when we write these questions or analyze these questions, and that is correlation and regression. The format is as follows. Is there a statistically significant association between grades in high school and mathematics achievement? Notice that I did not mark an independent and dependent variable here, and that is because it really does not matter when you are looking at a basic associational question. We're only worried about the variables, whether they're independent or dependent, if one occurs first in time. So, we need to consider the association between each pair of variables separately when there are two or more variables, and that's when we use a correlation matrix. For example, here's a question that uses this. Are there statistically significant associations among the 3 mathematics attitude scale scores? We would use correlation matrix to analyze those variables. If one variable is clearly the independent variable or predictor, we would use a bivariate regression. Here's an example. How well can we predict math achievement test scores from grades in high school? Notice the orange is our dependent variable and the yellow is our independent variable. We clearly knew that from our variable list in our question. A complex associational question should be used when there are 2 or more independent variables considered together. We would use multiple regression to analyze these variables. Look at our example at the bottom. How well does the combination of number of mathematics courses taken, gender, and father's education predict mathematics achievement? Here, if you look at the yellow, we are looking at a group of independent variables. Okay, we're looking at a group of them. Number of mathematics courses taken, gender, and father's education. And we're looking at how those independent variables predict the dependent variable, mathematics achievement. In review, we have covered the definitions of a research problem, grouping similar variables, types of research questions and formats, and types of statistics used for each question. Here is a list of our references. Please feel free to look these up and look at the research problems and questions presented in these items. In the Morgan, Leach, Glockner, and Barrett source, IBM SPSS for Introductory Statistics, you will find the information about research problems and questions in the appendix.